In this last video, we're going to take a look at the general multiplication rule using the same contingency table that we've been using. So I want to, in this quick example, find the probability that we randomly select a musician that plays guitar and received private instruction. Now, this is a problem, I'll admit, we don't really need to use the general multiplication rule. I can say, okay, first of all, we're randomly selecting a musician. So we are selecting out of the 192 individuals in our survey, and out of those 192, the individuals that both play guitar and received private instruction is 16. So I know my answer should be 16 out of 192. But just to illustrate the general multiplication rule, I want to get some practice working with it here. So the general multiplication rule says the probability of A and B is equal to probability of A given B times the probability of B. So I'm going to treat A as let's let A be guitar, and then we'll have B be private instruction. Okay, so the probability, first of all, that they play guitar given that they received private instruction. So that would mean I'm only considering, I am only considering this column, the private instruction column. So I have a total of 64 of those individuals. So 64 individuals that received private instruction. How many of them played guitar? Well, again, that there's 16 of those individuals. So 16 out of a total of 64. There's my first part. Times the probability of B, the probability that they received private instruction. So if I erase real quick, the probability that they received private instruction, I have 64 of those individuals, 64 out of a total of 192. And I would just multiply these together, and if we remember what we know about multiplying fractions, you can reduce across a fraction multiplication, which would mean 64 and 64. Those would reduce. They're both divisible by 64. So that would leave me with 16 times 1 gives me 16, and 1 times 192 gives me, well, 192, which is exactly the same as we had over here. So we didn't really need to use this formula, but it is good just to practice it. The one takeaway that I would think about when we're working with these and probabilities is, in general, when we're working with and probabilities, we are almost always going to be